Hi everyone, welcome to my channel Tech Tutorials 2K21. So today in this video, we are going to learn about the basic principles of C++ programming. So here first I list out what are the basic principles we have in C++ programming. Then we'll discuss about in brief about each and every principle in OOPS concept. So the first principle of object-oriented programming environment is object, and then we have a class, inheritance, polymorphism, abstraction, encapsulation, data binding, and message passing. So we'll see about all these concepts in brief now. So we start with a class. A class is a collection of data members and member functions. Or simply we can say class is a collection of objects. So coming to our data members, so data members are nothing but the variables which we declare inside of your class and the member functions. And these member functions are defined or declared inside of your class and which is used to operate on the data we specified in our class. So let us consider one simple example. So now you can consider student as a class. So now the student class will consisting two kind of things. One is the data members and the second one is a member functions. So now for the student, I'm going to give a data members as roll number, age, name and gender. There is the member function. So I'm going to take attendance and I'm going to get a habits of student and then I'm get the internal marks of the student. So these are the functionalities I want to do with a student class. So now this is a representation of class. A class can be represented like this. Like we can have a rectangle box there. It is divided into three parts. The first part will consisting the name of the class. And the second part will consisting the data members. And the third part will consisting the member functions. And coming to an object. So object is nothing but it's a real-time entity in object-oriented environment. So we simply say it's an instance of a class. And object is having both state and behavior. So you can consider in real world, you can take any thing we consider as an object in object-oriented environment. So it can be existed in a real time. Then only we can treat as an object. Otherwise, we cannot treat as object. So we have a different objects like you can consider your classroom. So now students are the objects, teacher is an object, whiteboard is an object, chalk piece is an object, table is an object, fan is an object. You can feel those things in a real time. So we can treat everything as an object. So in a previous slide only, I'll show you the class as a student. So for this, if I'm going to create a different kind of objects for a class student, so then here you can see I'm created three different objects. Okay, so now the first object is going to represent the roll number 521 with age 16 and the gender is male. And the name of the student we taken as Rahul. And the hobbies of this particular student is reading books and the attendance he got as 89%. So now you consider another object. So that is a female, that is a girl, which is having a roll number 62 and having age 16. And the name of the student is Sahiti. And the hobbies is dancing and attendance she's having 90%. So remember, we can create any number of objects for a given class. So here I created three objects. So we'll see in brief how you're going to create objects in C++, that is in brief later. So now consider the next thing is an inheritance. So inheritance is a process in which an object of one class is acquires the properties of another class. So by using this inheritance concept, it supports the concept of reusability in C++ programming. So what simply we can say about an inheritance is we have an existing class. From that existing class, we are going to create a number of classes which is said to be a subclasses. And those subclasses will get the properties of the parent class too. So here we consider one example. Suppose we have a parent class shaper. So now from that parent class, we can create different shapes. Let's consider circle is one shape, rectangle is another shape, triangle is another shape. So these we can consider as child of a parent class shape. So in object-oriented environment, especially in C++ programming language, we have 6 different kind of inheritances are existed. So the first one is a single inheritance. So now you can see here we have 2 classes. So the child class or the derived class is inherited from the parent class. So the parent class is said to be base class, super class. Okay. And then it is also said to be a parent class, whereas the derived class is said to be child class, and then subclass we can simply say. So coming to a single inheritance, we have one parent and one child class. The child class, it acquires the properties of the parent class in this manner. And coming to this is a hierarchical inheritance. So in this hierarchical inheritance, we have one base class and we have n number of child classes. So in this example, I'll show you 3 child classes which is derived from the base class. And here it is a multiple inheritance. So the multiple inheritance is nothing but we have more than one parent class. From that, we are going to derive one child class. So in multiple inheritance, we get a ambiguity while implementing the program in C++. So because of that reason, multiple inheritance is not directly implemented in object-oriented programming language. So we'll see in brief about all these inheritances concepts later. And then coming to here, it is a multi-level inheritance. In this multi-level inheritance, you can see we have a multiple levels of classes here. So here we have a parent class, it is, and here it is a grandparent class, and it is a child class. So here we shown for a simple understanding, we are taking 3 levels here. So now the grandparent will be the base class. So from that, the parent will be act as an intermediate class for between the grandparent and the child class. So what is the meaning of this inheritance? The child class can acquire the properties of the parent class directly, and the child class is acquires the properties of your grandparent indirectly through the parent class. So this is a multi-level inheritance, whereas this is a hybrid inheritance. When we consider the hybrid inheritance, we can take any 2 combination of inheritances. Like you can consider your single inheritance and multi-level inheritance, you can combine and you make it as one inheritance that is said to be a hybrid inheritance. So simply we can say hybrid inheritance is nothing but it is a combination of any 2 existing inheritances. And in this is a new thing we have in C++, rather in other object-oriented programming environments, that is a multi-path inheritance. And now you can see here in this multi-path inheritance, and this is your base class. And from that base class, we can have 2 child classes. And from that, the next level, these 2 parent classes, these 2 classes will act as a parent class for this derived class. Now you can see that this child class is get the properties of these 2 parents, and then this base class also in an indirect. In a direct path, we are existing. See, here it is in a virtual path, is existing between your base class and the child class. So this kind of inheritance is said to be a multi-path inheritance in C++. And then the next concept is polymorphism. So polymorphism is a concept where an object behaves in a different way in different situations. Simply, we can say object in many forms is nothing but a polymorphism. There are 2 different kind of polymorphisms are existed in object-oriented environment. The first one is a compile-time polymorphism, and the second one is runtime polymorphism. So the compile-time polymorphism is implemented by using overloading concepts in C++. That is, we are implemented object like operator overloading, function overloading. By using that, we are going to implement a compile-time polymorphism in C++, whereas the runtime polymorphism is achieved by using function overriding. So we'll discuss about this overloading and overriding concepts in depth. Then we discuss about a polymorphism concept. So let us consider an example for a polymorphism. Now you can consider here one woman is there. So now this person will plays many roles, depends on a situation. So suppose for assuming that the woman is at home, right? So she can act as a wife, sister, daughter, and mother-in-law, okay, and she can be a girlfriend to one boy. So now one person, not only when you can take in a real time any object, and that object is going to behave in multiple ways, then we consider everything as a polymorphism. So depends on a situation. Now see, for example, this woman, now she behaves like a wife, right, with her husband, and she behaved like a sister, and she showed the characteristic of a sister when she is with her sisters or brothers. So like that. Okay, so this is a real-time example we can consider for polymorphism. And then see data abstraction. So data abstraction is refers to it's providing only an essential information about the data to the outside world, and it hiding the background details or an implementation part. Let us assuming that Rohit is a person, he wants to withdraw an amount from an ATM machine. So now he went to an ATM machine and he going to enter his password, and he's going to select an option like amount withdrawal or cash withdrawal. So if he validated in a correct way, like he entered his password correctly, then he redirected to withdraw his amount. So the ATM machine will take care to connect with the bank, and it will check the availability of money, and it compares with the withdrawal amount. If it is sufficient, then Rohit will get the money from ATM machine. So why we consider this is an example for abstraction? Because the Rohit will know that when he enters to ATM, no, he wants to enter the 4-pin password, and he want to give a correct information what he want to do with the machine, but he don't know the internal details when he enters the password, how the machine is going to validate, how it is going to operate with the bank, and these internal processing is not required for the Rohit. So at the end user, for such applications, he knows only the interface part. He cannot know the functionality. And that we can simply say data abstraction. So simply it is going to implement it in object-oriented environment by using data abstraction concept. And coming to an encapsulation. So encapsulation is somewhat similar to a class as a definition wise, but here the difference is for a class we can make it as a public, everybody can access it. Whereas encapsulation, there is a restriction, means the wrapping up of data and methods into a single unit we call it as an encapsulation. So now the data and the methods is to be wrapped and it is to be protected in C++. So we use access specifiers, concepts like public, private, and protected to implement the encapsulation concept by simply used getter and setter read-only methods. And then encapsulation is helps to keep the related data and functions together, which makes our code cleaner and easy to read. And it also helps to control the modification of our data members. So by using this access specifiers, we can provide the current authentication to the different kind of users. And message passing. So we know that in object-oriented environment, it is combination of objects. So we can consider everything as an object in object-oriented environment. So for an application, so all these objects is going to be communicate with one to another to run an application in a smooth manner. So objects can communicate with one another by sending and receiving the information. Simply we can understand that. So we know we are implementing different methods or functions in programming. So we have a calling method and caller methods we have. So now they are sending some request. We see here a message for an object is request for an execution of a particular procedure, and therefore will invoke a function and the receiving object then generates the desired result. So now we are calling one function. So the compiler will do it, invoke the function, and it did the functionality which you are given in a function, and it returns back to the function for receiving the result. So message passing is involves specifying the name of the object and the name of the function and the informations to be sent. So simply we are creating objects for a class. By using that object, we are calling your functions, and whenever it is required, we have to pass the data to functions. And coming to a last concept in OOPS principle is data binding. So data binding helps to linking a function call with its corresponding function definition. So now the function definition is going to define a procedure what we are going to execute. Whereas the function call, it invokes the respective function for implementation. And the process of matching a specific function call to a respective function definition is said to be binding. So in C++ or in object-oriented environment, there are two kinds of data binding. One is static binding. The second one is dynamic binding. So the static binding is also known as a early binding. So it is done at compile time, and it is achieved in C++ by using function overloading concept. Whereas in dynamic binding or a late binding, it is done at runtime. So in C++, this concept is implemented by using simply the function overriding concept. So we'll see about the function overloading and function overriding and how we are going to achieving this binding concepts in C++ program when we discuss about data binding concept in brief. Thank you.